Alright, this is number 33 on page 342, and in this problem we're supposed to write the function, quadratic function that has a maximum value of 6 when x is equal to negative 2, and have one of the zeros, which is an x-intercept, is 1. So that's, crossing the parabola crosses the x-axis at 1, 0. So just by making a little working sketch, there's a lot of information we can get by kind of plotting those points and taking a look, and then we'll write the equation. So the maximum value of 6 when x is negative 2 is just a way of telling me that the vertex is, when x is negative 2, y is 6. So if that's the case, 1, 2, 1, 2, 3, 4, 5, 6. So my vertex is up here, and my axis of symmetry goes through that. And my axis of symmetry is the vertical line x equals negative 2. And it tells me one of the zeros, which is another word for x-intercept, is positive 1. So that means that this parabola must open down, because it's going to cross here at 1. So it's going to be going like so, down. And I know it must be symmetrical about this axis line, so I can find the other zero this way as well, just using symmetry. So I'm 1, 2, 3 to the right here, so go 1, 2, 3. So this other zero must be at negative, this is negative 2, 3, 4, 5, at negative 5, 0. So my other x-intercept is negative 5. So I've got x-intercepts of 1 and negative 5. So that's a way of just saying that's the roots. They're 1 and negative 5. So now I can write what I know about this function, because all I really don't know is what's the value of a that when I write this in standard form. So I know that I'm going to be using y equals a times x squared minus the sum of the roots times x plus the product of the roots. And I can solve for a as long as I have one ordered pair, one point that's on this parabola. So if the roots are 1 and 5, I'm going to use the fact that the sum of the roots is 1 plus negative 5, or negative 4, and the product of the roots is 1 times negative 5, or negative 5. So I know that y is going to be equal to a times x squared minus negative 4x. So that would be a plus 4x plus negative 5 would be a minus 5. Okay, now once I've got that far, to find out the exact value of a that's going to make the vertex, we know for any equation with this format, x squared plus 4x minus 5, we're going to have these two roots. But of course this vertex could slide up and down this line, and I could vertically compress it or stretch it by changing the value of a. So to find the a value that goes with this particular vertex, negative 2, 6, I'm just going to plug in an x and a y that I know. So I'm going to take this x and this y that are in the vertex and use those. So y, the y value of 6 is equal to a times x, so negative 2 squared, plus 4 times x minus 5. So 6 is equal to a times, if I simplify this, this is 4 minus 8 is negative 4 minus 5 is negative 9. So if 6 is equal to negative 9a, then when I divide through, a is equal to negative 6/9, which is negative 2/3. So now I can put that back in for a here. So the equation should be y is equal to negative 2/3 times x squared, actually put it here, plus 4x minus 5. And that's one form of it. The book shows this, distributed to each term. So it would be y is equal to negative 2/3 x squared minus 8/3 x, and then negative 5, so plus 10/3. Okay, so either form of those would be the function that it results in this graph of the parabola. So that's it.